repeat this transformation to get next iteration of this curve. It will be this one, sorry, and this one, right? Yes? This one, and this one, etc. So zipper is a system of maps which is organized in the following way. We have initial interval. We can consider it is an unit interval, right? And we have some polygonal line with arrows. Yes? And each map sends the whole interval to the beginning and end of each of the subsequent intervals, so that beginning is sent here and the point 1 is sent there. And the direction of the arrow is the signature of this zipper. So the signature of the zipper will be 0, 0, 1, 1, 0. Yes. 0 when we preserve the direction, yes, and 1 if we invert the direction, yes. So here there is a picture when such zipper is constructed. So I will explain it in words. So it begins with the name of the main block. We call it G. Then we write that this block is considered, is checked, because some blocks which are used for some special computations, they are hidden. They are not shown on the screen, but the results of these blocks is used. Then after that, I write the name. The name. So A is attribute, and this is a name. And name will be zipper. So when we begin to look at this, so it will be, after that, we specify the dimension. Dimension is 2. Unfortunately, we can use dimension 2 or 3 only. Yes, in dimension 2 this program works well. In dimension 3 it works also good, but more slowly because the computations are more large. Then there is a special feature of this program. I don't know, because there are many versions of this program, but the author specifies in that way, since angles are measured in radians, he needs to define the number pi, and he defines the pi in this way. Pi is 2 arcsines of 1. So it is strange, looks strange, and we still do not question the author why he does so, because he could just define pi from the very beginning without specifying, and then we begin to define different numbers. For example, when we draw zippers, we used to draw intervals. Yes? An interval can be considered as a self-similar set. So we draw, here it is written in a very good, it's not good manner. So I define interval the following way. Interval, it is not shown, therefore I write ampersand here, is defined as the 0.5 multiplied by union of two maps, first identity, and then, so the vertical line means union. It means union of operators, it means union of objects, so, and star means composition. So, this is a definition of the interval. Do I need to explain it? Yes? So you see that x is 1/2 of x union 1/0 multiplied by x, right? So if we have interval, yes, and interval, we take interval, translated by 1/0, this is a translation by 1/0, yes, and then shrink it to time, for 1/2, yes. So this is a definition of interval, and if I delete this sign, ampersand sign, I can do this. So if I apply this block, then I will see what is defined by it. So here you see three objects which are defined by this zipper. So first it's a polygonal line with arrows, second the attractor, and one more attractor, but we need to change the variables here. So we define interval, and at that moment I delete this sign, ampersand sign, so we can see interval itself. When I delete and apply this operation, then I will see now interval appeared in the list of values, yes, and we can look at it. You see? Okay. 1 second. If you need to magnify it, just do this way. So if I wish to magnify it, it is not a problem. I just put the frame here and automatically it will be magnified. The next object which we have here is an arrow. You see these letters? Do you see? Is it visible? I don't know how to magnify the letters. So I deleted this sign and interval became visible. And now I write arrow is equal. So I take interval, unit interval, and make its union with with the arrow. So how to draw an arrow? I take interval, I take 0.75, yes, and attach here two small intervals, yes. So here it is written, I don't see, so I take 0.75, 0.75, 0. So what does it mean? AB. In dimension 2, AB means a two-dimensional vector, yes? Two-dimensional vector with coordinates A and B. And also each vector defines a translation. So it is not only a number, it's also a translation operator. So if I write AB multiplied by I and T, it means that I will draw the unit interval which is shifted to the point AB. Yes? And if I write AB multiplied by 1/2 multiplied by I and T, it means that I have an interval of size 1/2 shifted by this side. If I write, for example, 1, 0, union 1, this is union of two operator. One is identity operator, this is operator one shift. Yes? So I write the interval is 1/2, right, multiplied by union of unit interval and this interval shifted by 1, 0. Okay? Therefore, it is the definition of unit interval as a self-similar set, and this definition automatically constructs the set. Oh. What do you wish?
I just want to see the font.
What?
This screen. You come here, sir.
Yes, 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 yes.
Slide it in computer. We view, then setting. Yeah, here we can increase the UI scale. So, UI scale. Now you type here something, thus 10.
What?
This scale you increase. 3.1 to increase.
I think.
Yeah. You go here.
Yes.
It is not.
Oh.
Correct? Fine? Now you go back. Now you go back. No, no, no. Go back here. Come out from this.
Yes.
Go out.
Yes.
Now your size increase, no?
Oh, thank you. How did you find this? How did you find this? This is wonderful. If also you could show me how to move this screen. Huh? Yes, so I don't need to write anything, yes. Okay, so this is the, oh, sorry. We enlarged the text too much. I need, this program is very sensitive to all kinds of interferences. Okay, that's, so we have, you have, this is, oh yes, I need to explain to you what is ABCD. What does, if we have AB, we have a vector, yes? And vector is also a translation operator. But if we have ABCD in dimension 2, it means Of course, in dimension 4 it would define a 4-dimensional vector, but it doesn't work in dimension 4. ABCD is a matrix. So A, B, C, D. So this is a fine map. And here you see 1 minus 1 half, 1 half, 1. Sorry, how to erase this thing? Okay. What does it mean? It means that I have unit interval, then I diminish it. I take 7 hundredths. Yes, 7 divided by 100. Put it here and put two small intervals at the angle which is arctangent of 1/2. Yes. So it's quite good. So this will be arrow. So we define the arrow. Yes. And now we define randomly chosen number from the interval between 0 and 0.5. So it's a comment which is not easy to remember. So I write x1 is dollar number. So if you put a dollar sign, this is some special word in the program or special symbol in the program. For example, dollar name, dollar attribute, and dollar sign number. So we have number, and it is number may be real or may be integer. Yes, so it's real, and since it's real, it can be chosen from some interval. So it is between 0 and 0.5. 0.5 means 1/2. So this is first number. So we have, what does it mean? This means the following. I have 1, 0, I have 1, and I need to define 2 points which are randomly chosen. So this point is x1, y1, and this x2, y2. Yes, and also we have arrows defining this zipper. Yes. So this program defines zipper with 4 vertices and consisting of 3 segments. So here it is. Yes, it is not good that we choose this. I can make it a little better. For example, I can change the number so that this zipper becomes more humane inside in its vision. So suppose I delete this and take this 0.5. Oh, no, 0.25. I take x2 0.75, right? And don't allow y1 and y2 vary too much. So they will be varying to smaller extent, and I can apply it. and look what result we'll have. Wow. Very strange. Very strange. The result is 2. Oh yes, because I look at the interval. A zipper is that. You see? So we have a curve. This is 0. This is 1. This is 1/4. Yes, on this line, and this is 1/4. And these are two random numbers. So it shows the polygonal line, because when we draw a zipper, we need to see a polygonal line. Yes, and we need to see arrows. So it is very good auxiliary construction, which helps us to make. And let us look at the attractor. You see? So this is the attractor. Is it visible? Okay. Yes, but how to check how this attractor correlates with this initial curve, Z101? This will be this one. You see? So problem may appear how to change parameter. So we have two parameters, y1 and y2. You see? Do you see the parameters? And let us change the parameters. You see? I can change the parameters, and the zipper curve changes accordingly. And we can change also the second parameter. So we can put it to the bottom, yes, and this also to the bottom. So when we defined in the program source, we defined randomly chosen parameters, then we can go to the control window and vary them. So varying them will get different objects, and we can attach them. So now there are some special programs, SIM, special commands. They are very simple, and I will show how they are defined. If I find the parent block, if I don't find source, sorry, 1 second, not one. Oh, maybe I need to use some editor. Oh, so month. So if we take an interval AB and send it to CD, we can define special procedure which sends this interval to this one. Yes? So it will be SIM of ABCD. Yes? This SIM it sends the interval 0, 1 to the interval 0, 0, XY. So it is defined separately, but now I cannot I need to find it in some programs because I cannot write it. It is very simple. Sim A, B, C, D sends 0, 1 to vector from point A, B, C, D. So it will be, it is the following way: sim of A, B, C, D, B, C, D is it's a translation by AB, and composition with matrix. A matrix will be C minus A, B minus D, D minus B, C minus A. Right. Yes. If you so matrix is written in the matrices are written in the linear form, so it will be AB multiplied by C minus A, C minus A, B minus D, D minus B, C minus A. So this sim ABCD means this this abbreviation. Yes. So we have first map sends 0, 1 to 0, 0, x1, y1. S10 sends this interval to the backward interval. Yes. S12 sends 0, 1 to x1, y1, x2, y2. So this map is used for arrows looking to the right, and this map is used for arrows looking to the left. So since we have Z10, Z1001, so it has a signature Z101, therefore we use S10 here, then S12 here, and S32 there, because we have signature 1. Okay. So this line shows that we construct a figure from arrows. Yes? So this is Z101, it is here. Yes? And D101 means the attractor, so it's the very zipper, and ZD101 is a composition of these two objects. Okay. Oh, sorry, one. So let us consider some other program. Okay, I don't see. Let So please look here. This program constructs a fractal square. What does it mean? What it means, a fractal square? A fractal square is a special kind. So Do you know Bedford McMullen carpets? Yes.
Can you show a small program which builds a basic structure, like a V-shaped square?
V-check. Okay. If I find it. 1 second. So, let us look at the Levy curve. Oh, no, Levy curve was just... Okay, let us look at the Levy curve. Sorry, but this... do you see it? Yes? So there are many additional components, but the very Levy curve is here. So first, we defined unit interval because we use it for our constructions. Then we define arrow. Then we define something. Oh, this is I think this is a square or something like that. Oh no, this is a triangle. You see, this is a triangle. Yes, and S1 and S2 are the two maps. Sorry, what to do with this thing? Yes, these are two maps which define the Levy curve. So if we delete all the other things, so Levy curve is defined by these three relations. I can show it to you how to do this. For example, I can delete all the other things. All the other things. I delete arrows, I delete triangles, I delete everything. And we have a program for constructing a Levy curve. And I will put into some, I will make it Levy curve 2 and make it one additional block. Yes, so I will proceed to this block. Sorry, I cannot find it. Michik, Serpinski. No, I don't know. Okay, so look at the Vichik fractal. 1 second. Vichik fractal. So it is very simple program. So this is the name of a block which means nothing. This is the name of the fractal which means nothing. This is just a dimension, and this is the definition of this set. Do you see? Please look. So we have an operator S, which is 1/3 multiplied by uh, five translations, 0, 0. So if we take a square 3 by 3, yes, then these vertices will have the coordinates 0, 0, 0, 2, 1, 1, 2, 0, and 2, 2. So we take 0, 0, 2, 0, 1, 1, 0, 2, 2, 2. And the operator is, Hutchinson operator is contraction, 3 times contraction, multiplied by union of these translations. Yes. And K is the image of K under this operator. So the whole program which defines Wittig fractal consists of 2 strings. Yes. So if you wish to change it anyway, for example, if I change I can make the following thing, 0, 0, 2, 0, 2, 0, 1, 0, 0, 0, 2, 0, 1, 0, 1, 2, 2, 2, and apply it. Then we'll get this nice set. So we just shifted 1 square to this side and obtained the different attractor. Okay, I don't want to write anything. Or maybe I change. I change it in a new block. And this program is quite complicated because it has dimension 3. Since it has dimension 3, then we need to define, since we have dimension 3, we need to define some other things, because we have translations in different vectors in plane, and then we have rotation. Oh yes, because some parts of this program are defined externally, because rotation X, rotation Y, rotation Z are defined in the other part of this program, and I cannot look at it from this place. Okay, so maybe we can continue. Which way? I think that I explained most of the things, yes? And it's better to download the program. To download the program, you need to proceed to IFSTile.com. And it can be easily downloaded, yes?
But they are saying some functions are not working.
What?
Some functions are not working. They download.
One which defined as similar
Yes, because it is defined internally. It's I wrote so SIM of sorry, how it is SIM.
Okay, you made another program inside.
Yes.
You are calling that function.
Yes, yes, I can show you. Because it is, it cannot be read from IFSTile because it's in hidden blocks.
I understood that you wrote a separate code for that.
Yes, 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 I can show you this one. Yes. I just need to open. I just need to open the other program, but this program cannot be enlarged sufficiently. So this screen is good. Not, I cannot read from the screen. No, no, no. I cannot read even to I cannot even look for anything. So the only way is to no, 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 no. This is absolutely something unnecessary. No, no, you don't need
Just
to.
I just copy.
No, this is not the thing which I am looking for.
You just show me the screen.
Yes,
Show me the screen. What you
yes,
want to show?
yes.
That
No. I need to open some file. Open. No.
no, why this font is very small?
Because the resolution of the screen is large and
Okay,
this
okay.
program adapts to this
Okay,
screen.
okay.
Yes.
Because of
You
that.
see,
Okay, I understood.
the problem of I told you there
I
is a
understood.
problem
I
of
understood.
buttons.
I understood.
Which button to press?
Okay.
Other problems are not so huge.
You open, we will copy it in some Word file and magnify, try to magnify.
Yes, 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 but oh, yes, I can do this.
Yeah.
So if I switch off this screen,
Okay.
then
Then will be good.
I am freed from this curse. Yes, okay. Yes, yes, yes. So x2 minus x1, y1 minus 1, 2. So I wrote it in more humane form, A, B, C, D, and it was better visible. Then y2 minus y1, and then we have x1, x2 minus x1. Yes. So this block being put in your program defines this program SIM, which sends 2 points to 0 and 1 to these 2 points, x1 y1, x2 y2. And also very important function is rotation. It is defined the following way. Rotation is defined, so it is also hidden. It is not shown anywhere. Yes? It has a variable a, which is initially 0, and it returns a value of cosine of a minus sine of a, sine of a, and cosine of a. So this means that it returns a matrix cosine a minus sine a, sine a, cosine a. Okay. What are else questions? Right?
There is a matrix multiplication there, right?
What?
A 1 by 2 matrix is multiplied by a 2 by 2 matrix, right?
This is a this is an operator of translation, and this operator is a fine map because it's not a matrix, it's a multiplications of operators. Yes. So initially there were very awkward long expression for all this, and the author of this program invented very compact language in which we can we can use sets and operators very freely. So we can apply operators to operators and operators to sets. We cannot apply sets to operators. But in some sense also, because if we have union of operators, so we can apply the union operators to some set or to some operator. So therefore it makes the notation very compact. Yes. Initial versions of this program made by Dmitry Mikhontsev and his friend Alexei Kravchenko, which are dated back to 2000, 3 zeros, yes? Yes, they were very large and awkward. There were many windows, and these windows had to be filled with some symbols. But finally, he came to Kravchenko is a programmer, and he works now in Kaspersky Labs. so he's very busy, yes. But Mikhontsev is also a programmer, but he also works intensely with Christoph Band, yes, because when Band came to know him, so he took him and began to use this program, yes. So I think he works in Huawei, programming in Huawei, but all the time he is making his beloved program IFSTile, and it becomes more and more perfect because it is used on its quality and fastness is based on arithmetic computations, which are faster than for example, a real value computation. Okay. So maybe we need to install this program and begin the practice. I think that I explained main topics, yes, and now I don't need this board. And can we shift to this computer lab? No? What? Ah, yes, they are recording. So I should continue talking. So in this case, I will explain how to build some good zippers. Sorry. Does it work? No? What it is? Source? Can we? No, say. Screen sharing? No.
Click to the source.
Source?
Source.
Yes, I see.
Now it's connecting.
Oh, it is thinking and okay. Oh no. Okay, so let us begin with von Koch curve. What kind of fractal do you we supposed to build now? We can make, for example, we can construct some kind of a deformation of von Koch curve. So suppose we have an interval. We divided it into 4 parts. Yes. And then we begin to move this point to that position. Yes. We will try to deform this. So we consider this zipper. it will contain the point 0. This will be, for example, 1/3. This will be 1/2. This will be 2/3, and this one. Yes? We need to define the self-similar set, and we're supposed to change this parameter from 1/2 to 1/2 plus h. Maybe let h belongs to interval, for example, from 0 to how large can we choose? I think it's better to 0 to, or maybe 0.4. Not so much, yes? And we're supposed to make this. So we defined 4 maps. First map will send this interval to 0, 1/3. S1 will be 1/3. S1 will be just 1/3. S2 will be, really it will be a map which sends 0, 1 to 1/3, 1/3 0, and 1/2 h. Yes? So it will be sim of 0, 1/3 0, 1/2 h. Right? S3. If this will be a zipper with signature 1111, S3 will be SIM. It will be 1/2 h and then 2/3 0. Yes, and S4 will be one. So we need to make 1/3 contraction of the interval and then translation it by 2/3. So it will be 2/3 0 multiplied by 1/3. So we defined these 4 operators. If we don't try to define this SIM, then we can write it directly. So write directly, it means we need translation to 1/3 0. Yes? And then we need to make such a rotation. So it will be a matrix which sends 0, 1 to this one. So we find this difference. This difference is 1/6, yes? And this difference is h, right? Is h. Therefore, the matrix will be 1/6 minus h, 1/6. Right? The matrix which takes the interval 0, 1 to the interval with coordinates 1, 6 and h is the following. Right? Okay. And here we have also the same things. We have we replace this, I will write this here, S3 will be translation by 1 second h, and a rotation by this to 1/6 h minus h 1/6. Okay, so we'll write these things. So we draw write h is a number, it's real, it is taken from interval from 0 to 0.4, yes, and then we have to write that k is equal to S1, S2, S3, S4 multiplied by k. And this will give us this curve which deforms from interval to von Koch curve. I can make it the following way. I have this program and I can write here along with Wittig fractal one more object which is specified this way. So I begin editing the program, you see. First I need to define this, this vector h. So I write h equals number which is real, and it is changing from 0 to 1/4, right? 0.4. 0.4. Then I write, so being very lazy, I just write the equation. I called it KK, Koch curve, and I write this four maps. First, I take the union of 1 and translation to 2/3 0. I take the union, and the union is denoted by a vertical line. I don't know why, but it is very convenient. You see? And then I multiply it. Oh, sorry. and multiply it by 1/3. Then I multiply this by 1/3. And then I take the union of this operator with two very long operators. Very long operators. How to do this, I don't know. Maybe I will act the following way. It is more convenient. So I type it, so 1/3, 1/3, 0, right? Then press star, 1/6, 1/6. Then it will be minus h, h 1/6, 1/6, right? And second will be second will be second will be 1/2 h, 1/2 h, multiplied by the similar thing, it will be 1/6 h minus h 1/6, right? And all this, we unite all these operators in one union. Shift 1. Then and apply it to KK. Okay? And now we need to apply. If everything is without mistakes, then it will work. So it applies. Okay. Then you see, there is the result, and this result can be changed because we can change the parameter. So, you see, it works. Are you satisfied? Of course, we are not satisfied with the with the number which we with the restriction on the numbers, then we can make minus. Yes. And even make minus 49. Yes. So are there any questions?
So show us the source code again. That
What you say?
so show us the code that you have written once again.
I don't hear.
So please show us this again so that we can get what you have written here.
Ah, yes. 1 second. 1 second. I need to go there.
Source.
And
Source.
oh, the source is here.
So shift into the towards right. We can see the
What?
whole code. We are not seeing the whole code in the last line. So shift
We
into
don't see the whole code. No, this is the whole code. You mean you need to see other blocks? Uh,
this screen. Yeah.
no.
Go
It
towards the right.
this block is shown completely.
So there is one more block to this, na?
No. Ah, you mean that the line is longer.
Yes.
Sorry. I can improve the situation. Yes. This is no problem. It will read. It won't suffer if we write the operators in this way. This program doesn't suffer from this. Let us check. Yes. Okay, and oh no, sorry. Oh. Source, and we can change the parameters, controls, yes? So nothing changed. Yes, but of course we can change some other parameters, something like this points 1/3 to third and all this. Yes. What?
Can we switch to the source?
Yes, 1 second. So now this block, wow, sorry. So now this block doesn't correspond to its name because there is not only Vichek fractal, but also we have this transformation on von Koch curve. Okay. Okay. So let us make some other things. Maybe we can make some deformation of So in this program you have the Vichik fractal, you see it, right? It is here, right? So consider the following problem. Yes, we have a Vichik fractal. It is obtained by sending the square to these 5 smaller squares. Can I continue? Yes. Thank you, thank you, thank you. Let us do the following transformation. I suppose to rotate each of these squares by some angle alpha. Yes? I mean, I take a square, yes? Then I have some rotated square here, a rotated square here, a rotated square here, and rotated square here. They must be of equal size, yes? Right? And then connect them by this square. So it will be a deformation of this Vichik fractal. And suppose to look, let us look how this deformation will look like. But this is not very easy, but it is possible to do. Fortunately, these angles are the same. And these 4 maps are also the same. Since these 4 maps are the same, we can construct them in 2 scratches instead of 8 ones. So we have here some vector, yes? Maybe let us define this vector by AB. Yes. So A will be approximately 1/3 or something like that, and B will be some negative value, maybe minus some kind minus H. So it will be A minus B. So and B belongs to some interval between 0 and say 1/6. Yes? Okay. And then let us consider the map which sends the whole square to this distorted square. It is not a problem. This map sends, if this is the unit interval, this map sends unit interval to A minus B. So this map can be written in the form A, B minus B, A. Right? This map is defined by the matrix A minus B minus B, A. Can you check this? Let us consider. If you have this matrix A, B minus B, A, and apply it to the vector 1, 0, what you have? B No. A minus B. So this vector goes here, right? A minus B. And if I take the vector 0, 1, I will have this be A, right? So this matrix was defined correctly, which, okay. Now we need to find, then we have this matrix, and it will be repeated 4 times, but it is not good to use it, right? Oh, how to use this? Since they are look the same, but they are different, right? In which sense they are different? If we consider translations, then we need to consider these 4 points. It's easy to find them, but not very easy. Yes, but if we use the symmetry, it will be much more simple, because do you know what transformation sends the square to itself and rotates it by 90 degrees? Can you write the transformation which sends the square, unit square, to itself, but rotates its vertices? Do you understand? So it sends 0, 0 to 1, 0, 1, 0 sends to 1, 1, and 1, 1 sends to 0, 1. So it's a rotation of the square with respect to 0 plus translation by 1, 1. So this map will be 1, 0 multiplied by 1, 0. No, sorry. 1, 0. We need to make this rotation which sends 1, 0 to 0, 1 and 0, 1 to minus 1, 0, right? So it will be 0, 0 minus 1, 1, 0, or not? 0 minus 1, 1, 0. It sends 0, 1, 1, 0 where? It goes 1, 0 goes to which vector? 0, 1. Okay, it's true. Yes. And if we applied it to 0, 1, it goes to minus 1, 0. So it's just the rotation which we needed. So you see, it's easy to consider theoretically, but when you begin to make constructions, you need to check possible appearing mistakes. Therefore, it's better to test mistakes in advance. Okay, so this operator will be, as I said, 1, 0 multiplied by 0, 0 minus 1, 1, 0. Yes? And it will be A, for example. It will be A. So I define this operator A. Yes. So we defined this rotation, then apply operator A, we apply these 4 squares, right? using symmetry, but we need to define this one. What it is? What is this vector? Do you know it? So it's A minus B. This is B minus A minus B. This is BA. Yes? So it will be A plus B. A minus B, right? This vector is A plus B, A minus B. Do you agree? Okay, it's okay. A minus B. And what's about this one? So we need to apply this rotation to this vector. So we need to, it will be, this distance is, second coordinate is A plus B, right? And first coordinate is 1 minus A minus B. 1 plus B minus A. Please check. I'm standing near the blackboard, so I have a very large risk of making mistakes. Right. So did you check? No, okay. I don't play such games. Please, please check. So this coordinate will be A plus B, A minus B, and this coordinate will 1 plus B minus A, A plus B. So we need to define this vector, yes, and it is 1 plus B minus A minus A plus B. Wow. Oh, so it's 1 minus 2A, right? B is y minus 2A, y minus 2A, right? And second coordinate will be A plus B minus A minus B to A. A plus B to B. Y minus 2A to B. Okay. Now we are in charge to write this deformed Vichek set. So it will be the following things. So we defined, you see, we defined the rotation, which makes this square, right? What is the rotation? It is A minus B, BA, right? This map sends the unit square to this one. Yes. And this map, it will be A plus B, A minus B. This point multiplied by rotation. Oh, yes. Multiplied by rotation. 1 minus 2A minus 2B, y minus 2A. So this map sends this square to this one. Okay. We can write the command. Oh, yes. Also, can you remind me what was the A which I erased just now?
Closed interval 1, comma 0.
What?
Closed interval 1, comma 0.
No, 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 no. No, no, no. No. This was a rotation. This was a rotation. It was first. Ah, yes. 1, 0 multiplied by minus 1, 1, 0. 1, 0, yes. It was A. Right. So we have to write the following way. So the operator will be 1 A multiplied by A multiplied by A multiplied by A. It's not very optimal, but it's good. We have 3 rotations. Then we multiply them by this map A minus BBA, BBA, right? And then add here this one. And add here this one. A plus B, A minus B, and this composition 1 minus 2A, 2A minus 2B, 2B, 1 minus 2A. If I didn't make a mistake, this will give us, this operator will give us this deformed Wittig set. It will give us this deformed Wittig set, and we need to type it down in our laptop and check if it works. So maybe this way, not sufficient number of degrees of freedom. Because I need to see the blackboard to make the computations. Okay. So first I define A. A is equal to 1, 0 multiplied by 0 minus 1, 1, 0 multiplied by 0 minus 1, 1, 0, right? And then we have this map. We have T. It is equal to 1 composition A multiplied by A. Oh, sorry. Does anyone repeat these things? No? Does anyone try to do the same? You are doing, yes? Oh, that's good. So, and it will be A star A star A. We close it and then apply it to A minus BBA. Apply it to A minus BBA. A minus B, sorry, B A, right? Not wrong, because I have a bracket. Yes. And then there is a vertical line, yes?
A plus B and A minus. In a square bracket, A plus B and A minus.
A minus BBA, right?
A plus B, A minus.
Yes, but there is a vertical line. We need to make a union of two operators. We make a union of two operators, and this one will be A plus B, A minus B. It's a translation. A plus B, right? Sorry. A minus B, right? Oh. And this is multiplied by 1 minus 2A minus 2B to be 1 minus 2A. 1 minus 2 star A minus 2 star B 2 star B and 1 minus 2A 1 minus 2 star A. Okay. So this is the operator T. I need to define A and B. Let us A and B be say 1/3. Oh no, yes. We need to define them some way. A equals 1/3. B equals 1/6. Right? Yes. And after that we write KKK. Oh no. KKK equals T multiply KKK. So if everything is correct, it will work. If not correct, it will give undefined variable. Sorry. Okay. No problems. Let us check if we have this. If we have. Do you see? It works. And now we can change some. So the problem was solved without mistakes. It's a great victory. It's a great victory because just without preliminary computations, just from scratch, it was done without mistakes. It's maybe it's first time in my life. First time in my life, yes. Now we need to make changes. Make changes because A, so we have H. Instead of H, we can use A. Oh no. Okay. Instead of, let B be equal to H. Well, let B be equal to H divided by 2. Not so large, because, and then we can change H and we can deform this thing. This pure thing will be deformed and we can see the deformation. 1 second, apply. Okay. Wow. Yes. Very strange, but it doesn't work. By some strange coincidence it worked, and at that moment it stopped. It stopped. So let us change the parameters. So H was yes. It was a there is some small mistake. Some mistake, yes. There's some mistake in our computations, but it is not for today. There was some very strange success. What is this? So we need to make some error checking, and after this error checking it will be improved. Most probably these computations were not correct. Somewhere the sign was changed. Let me check again. Oh, different sign. Yes, it should rotate a different direction.
Instead of minus b, b.
Yes, instead of minus b, it must be plus b minus b.
And similarly for minus 2b, it should be 2b and minus 2b.
Right, but let us check. Oh, yes, 2b and minus 2b. To be or not to be, yes, okay.
And sir, a minus, instead of a minus b, ba, it should be a b minus ba.
Let us make improvements step by step, because it is, wow, very interesting. So I change to B to minus to B, right? And something, yes, controls. Yes, there is a, I need to use some kind of sheet of paper.
You can change A, then B, then minus B, then A. Just below the function T where you have taken class.
Let us check, yes. I will follow your wise advice. Yes. Maybe it will do, it will, so I need, sorry, editor, A,
You have to apply first.
no, A minus BBA, A minus BBA was, oh yes, apply. It is rotation this in, oh yes, A minus BBA rotates counterclockwise, and I need to rotate it clockwise. B, AB minus BA, because B is positive, right? But in that case, we need to change this. Translation. Play, yes. It looks great, but most probably we need to change all these signs. Okay, play. Now.
That should be A plus B, A minus B. Yeah, A plus B and A minus B.
Oh, do you apply the some random changes? No? Oh. Sorry. Oh. Controls. Ah, you're a genius. You're a genius, yes. Thank you, thank you. You saved all this example, yes. Fantastic. Fantastic. So we can change H to yes. Right. So the problem was solved. Yes. By very intense and effective cooperation. So what is the time now? Huh?
It's almost 6:20. 6:20.
And when we finish?
5:45.
What?
We have to finish by 5:45.
And now it's,
6:20.
so we need to continue till next 5:45. Yes, okay. Okay, so we continue.
Half an hour extra.
Huh?
No. We started late. We started late.
We started
Late.
late.
Yeah.
So we need to continue till 7.
No.